welcome to Neelam tutorial. In today's video, we'll be dealing regarding oxidation of different classes of alcohol, that is 1 degree, 2 degree alcohol. What will happen when we oxidize 1 degree, 2 degree or 3 degree alcohol? Next, iodoform test, which is the must asked question. Iodoform test, it's easy, but it's must asked question. Next, we have preparation of ethanol from cane sugar. Next, we have catalytic dehydrogenation of 1 degree, 2 degree, and 3 degree alcohol. And the last one, we have Grignard method of preparation of alcohol. So let's continue the video. So let's move on for what will happen when we oxidize 1 degree, 2 degree, or 3 degree alcohol. You might be very well known that the most strong oxidizing agent is KMnO4 or K2Cr2O7. So let's move on for the first heading, that is oxidation of primary alcohol, primary alcohol, which we also call 1 degree alcohol. Okay. So what will happen when we oxidize primary alcohol? Let's take an example. It is something like this, RCH2OH. Or you might be known that the alcohol, if the alcohol is connected to a carbon and this carbon is connected to one other carbon, only one other carbon, then it is 1 degree. Especially, you need to check the connection of this carbon in which the alcohol is being attached. If it is being connected with only one other carbon, it is called as 1 degree alcohol. You might be known about this. If you are treating it with KMnO4, which is a strong oxidizing agent in acidic medium, or K2Cr2O7 in acidic medium, either of this can be used, then we'll generally get aldehyde. What will happen is this group, this entire group, CH2OH group, will transform into our C double bond O H group. So basically what you need to understand is the alcoholic group gets transformed into aldehydic group. In the second stage, this further undergoes oxidation. This further undergoes oxidation and it gets transformed into, further if you treat it with the same oxidizing agent, KMnO4 in acidic medium or K2Cr2O7 in acidic medium, will get this aldehydic group will transform into carboxylic group, RC double bond O OH. So basically what is happening is primary alcohol is being oxidized too. So this was your 1 degree alcohol. Sorry. So this is your 1 degree alcohol. This will oxidize and it will transform into aldehyde. This will further oxidize to give carboxylic acid. Okay. And what you basically need to remember is the number of carbon in each of this group will be same. The carbon number will not fluctuate. Carbon number will neither increase nor decrease. That means if the alcohol contains 3 carbon, the aldehyde should also contain 3 carbon and the carboxylic acid should also contain 3 carbons. Okay. Let's move on for the oxidation of secondary, or we can also call it 2 degree alcohol. What will happen when 2 degree alcohol is being oxidized? So for 2 degree alcohol, what is 2 degree alcohol now? We need to know that. If you have R, the carbon in which the alcohol has been connected, it should be connected with 2 other carbon. If this carbon is connected with 2 other carbon, only then it will be called as 2 degree alcohol. Okay. Now it's being oxidized under the same oxidizing with the same oxidizing agent like MnO4 in acidic medium. This one, 2 degree alcohol will transform into ketone. What will happen is basically this group, this carbon hydrogen bond will transform into ketone. And this is going to be something like this, R, C, R, and this will transform into C double bond O group. So what is exactly happening over here is the alcoholic group is transforming into ketone. So 2-degree alcohol is being oxidized to ketone containing same number of high carbon atom. Containing same number of carbon atom. Carbon atom. Now what will happen is the ketone will not easily oxidize into any further compound. So it needs to be oxidized under drastic condition. If it is being oxidized further under drastic condition, so this can be oxidized but under drastic condition. Okay. Further, if you are gonna oxidize it under drastic condition means under high temperature and pressure and in the presence of catalyst. Okay. So this one will convert into carboxylic acid. But what you need to remember is this time the carbon number will decrease. Then what will happen? This bond is gonna break right over here and it will be like something R C double bond O OH. Okay. Along with the liberation of CO2 and H2O. So what will happen? The carboxylic acid, here is the formation of carboxylic acid. Okay. But the number of carbon will decrease. Okay. Means whatever is the number of carbon in alcohol will remain same. Means if it is propanol, it will be propanon. The number of carbon will remain same in ketone. But when it comes to carboxylic acid, it might turn to ethanoic acid. Means the carbon count will decrease. Okay. And it will not directly convert. You'll have to treat it under drastic condition. The third one we have oxidation of tertiary alcohol. Oxidation of tertiary alcohol. Tertiary here, 3-degree alcohol is we also call 3-degree. Now, what is 3-degree alcohol? Let's go for it again. If a carbon contain alcoholic group and if it is being linked with three other alkyl group, means three other carbon. So this will be called as if the carbon is connected, this carbon is being connected with three other carbon, then it is called as 3-degree alcohol. And basically 3-degree alcohol doesn't oxidize under normal condition. So if we are treating it with oxidizing agent, they will not oxidize easily. So we need to treat them under vigorous condition. Under vigorous condition, it gives us ketone. It will transform into what will basically happen is this bond will break and this bond will break and this one will transform right over here to give our C double bond O R. That means it is going to give you ketone. 3-degree alcohol here, 3-degree alcohol has also transformed into ketone. But this time what will happen is this time the number of carbon atom is less than alcohol. Whatever is the number of carbon atom in alcohol, the number of carbon atom in ketone will comparatively be less. Again, if it is further oxidized under vigorous condition, further if you undergo oxidation and under the same vigorous condition, it might give us it turns into carboxylic acid, RC double bond O, OH, along with the liberation of H2O and CO2. But this time again the carbon count will decrease. So here we have carboxylic acid, but the number of carbon is again number of carbon will further decrease. Further, that means whatever was the number of carbon in alcohol, it will decrease in ketone, which will further decrease in carboxylic acid. So that is what it is saying you. Let me repeat once again. So 1 degree alcohol gets transformed into aldehyde and then it transformed into carboxylic acid containing same number of carbon atoms. 2 degree alcohol gets transformed into ketone, which further having same number of carbon, which further gets oxidized under drastic condition to give carboxylic acid, but the number of carbon in carboxylic acid will be less. 3 degree alcohol gets transformed into ketone under vigorous condition with lesser number of carbon atom, which is further oxidized to give carboxylic acid containing more less number of carbon atom. So let's move on for the next. There we have iodoform test. So let's understand iodoform test. What exactly is iodoform test? So basically, iodoform test is only positive for the group having carbonyl carbons and a CH3 being attached with it. If the situation, if any of this group contain this thing, कुनै पनि compound ले यो COCH3 group carry गरेको छ भने त्यसले चाहिँ के गर्छ त iodoform test positive दिन्छ है त। अब कुरा आउँछ त्यहाँनिर 1 डिग्री अल्कोहलले कसरी पोजिटिभ दियो त त्यसो भए हैन। अब हामीलाई के थाहा छ त यहाँनिर इफ वी हेभ 1 डिग्री अल्कोहल ओके इफ आई हेभ 1 डिग्री अल्कोहल or ethanol. What is ethanol? CH3, CH2OH. Recently, what I said that this group can be oxidized into CH3, C double bond O, H. So here, can you visualize this thing? C double bond, CH3, CHO, CH3, C double bond O. So we can say that this will give a positive iodoform test. Next, what I can say is secondary alcohol having a methyl group. So 2 degree alcohol, if I have 2 degree alcohol containing like a methyl group. So at that time also it will give you a positive iodoform test. Or we can call it methyl secondary alcohol that contain methyl group in alpha position. In alpha position. In alpha position. So basically, if I have this, that I have 2 degree alcohol CH3, CH2, CH, CH3, and here I have a OH group. So what is alpha position for this carbon? This one is alpha position, or you can say this one is alpha position. So here this one is not a methyl group, but this is a methyl group. Okay. So how will it transform? So it may transform into ketone after oxidizing, and it will give us something like this. CH3, CH2. This will be C double bond O. And here you will have a CH3. So can you observe this C double bond O CH3 group? So yes, it will give positive iodoform. That's again, if you have acetaldehyde. So aldehyde, among aldehyde, only acetaldehyde gives a positive iodoform test. Because acetaldehyde is the only aldehyde, that is CH3 C double bond OH, is the only aldehyde having this group CH3CO. And the last one we have methyl ketone. If you have methyl ketone, that means the ketone must contain a methyl group, and other than that, there can be any other alkyl group. In this condition, this ketone will also give positive iodoform test. So these are the 4 situations where iodoform test will be positive. Other than this, iodoform test will be negative. Now, what is iodoform test? Let me explain about this. So iodoform test is basically, for now I'm treating it with ethanol. So what is ethanol? CH3, CH2, OH. If I'll treat it with NaOH and I2, okay, it will get transformed into CHI3. That is what we call iodoform. And it will give a precipitate along with the liberation of two molecules of NaI, five molecules of water, and a molecule of HCOO and A. Here you have six molecule of NaOH, and here you have four molecule of iodine. So balancing work can be done. So basically in iodoform test, if you treat a given compound with NaOH and I2 and it gives you a precipitate of CHI3, that means it shows positive iodoform test. When will iodoform test be positive? When there is a carbonyl carbon with CH3. If there is COCH3, only then the test will be positive, else the test will be negative. Let's move on for the next thing, that is preparation of or fermentation, what we can see. Here we have, or the process of preparation of alcohol from sugar, whatever topic we took in the beginning. What was the heading? Preparation of ethanol from cane sugar. So let me take that. Preparation of ethanol. Preparation of ethanol from cane sugar. So basically here we have what is cane sugar to C12H22 H22O11. So this is basically your cane sugar or sucrose. If it is being treated with the water, an enzyme that is known as invertase, it will give C6H12O6. And again we have C6H12O6. It will generally give a mixture of glucose and glucose and fructose. This mixture of glucose and fructose is further being treated with an enzyme known as gymase. It is further being treated with the gymase in order to produce ethanol, two molecules of CH3, CH2OH, and this process along with the liberation of carbon dioxide. And this method of preparation of alcohol is known as fermentation. So what is right over here? The very first sugar was treated with invertase to make glucose and fructose, which is further treated with zymase in order to form ethanol. So this is one of the technique for the preparation of ethanol from cane sugar. And the process is also known as fermentation. Let's move on for the next one. Synthesis of alcohol. So here we have synthesis of alcohol using Grignard reagent. So all these questions are most important ones. These are repeatedly being asked in most of your exams. So here what we have is, if I have, how can we convert? So what is Grignard reagent? Grignard reagent is RMgX group or alkyl magnesium halide group. It can be Br, it can be anything, RMgX. Okay, so basically it is alkyl magnesium halide. That's your Grignard reagent. So if your Grignard reagent is being treated with aldehyde or ketones, if I have R, C double bond O H group. Okay. What will happen is the bond will break right from here. Oxygen will have delta minus charge, carbon will have delta plus charge. If the bond breaks right from here, this will have delta plus and this will have delta minus. So what you can get is this R will directly come and attach with this carbon. And this MgBr group will move and attach to this oxygen. And the reaction takes place in the presence of dry ether. Sorry for this we don't need dry ether, sorry. So what will there be is R, C, H. In the C, there we have attachment of another R, and in the O, there is an attachment of MgBr group. Further, it is being treated with water in acidic medium, or we can call it acidic hydrolysis. What will happen is this group, this MgBr, will take away the OH group. This may dissociate as H plus and OH minus. So this MgBr group will be taking away OH minus in order to form MgOH Br, and the other group, that is R, this will transform into R, C double bond, sorry, it will be R, C, here will be OH, and here will be the form, there you have R. So basically what I mean to say is your aldehyde is being transforming into 2-degree alcohol. So aldehyde gets transformed into 2-degree alcohol when it is being treated with Grignard reagent. So aldehyde got transformed into 2-degree alcohol. Similarly, let's take ketone. What will happen with the ketone? If I have ketone, that means if I have CH3, C double bond O, CH3 group, and again there is R, Mg, Br, that is Grignard reagent. What will happen? Again, the bond will dissociate. The R group will come and attach with the carbon, and MgBr group will come and attach with the oxygen. So the product those formed will be CH3, C, CH3. Here you have R, and here you have OMgBr. When you further go for acidic hydrolysis, this will give you CH3, C, R, CH3. Here you will have OH along with the liberation of MgOH Br. That means what I can say over here is ketone can be converted into 3-degree alcohol. So these are the techniques for conversion of ketone to 3-degree alcohol and aldehyde to 2-degree alcohol. The last heading for this video, we have catalytic dehydrogenation. So the name itself is clear, dehydrogenation. There we have catalytic dehydrogenation. Catalytic dehydrogenation of 1 degree, 2 degree, and 3-degree alcohol. So what will happen when 1 degree, 2 degree, and 3-degree alcohol is being catalytically dehydrogenated? So if we have 1 degree alcohol, that is CH3, CH2OH, and if we treat it with copper at a temperature of 300 degrees C, it gets transformed into aldehyde. This group, this primary alcohol part, this gets converted into aldehyde. That is, this will have CH3, C double bond O, H. Okay. So 1 degree alcohol gets transformed into aldehyde. This is 1 degree alcohol. Next we have, if you have 2-degree alcohol, that is CH3, CH, CH3, and if you have OH group being treated with copper at 300 degrees C, it will give us this group will again transform into ketone. That will there will be CH3, C double bond O, CH3, along with the liberation of H2. So 2-degree alcohol, what we can say is that 2-degree alcohol gets converted into ketone. Okay. And next you have 3-degree alcohol. If we have CH3, C, CH3, CH3, and here if you have OH, and if it's again being treated with the copper at a temperature of 300 degrees C, this OH group and one of the hydrogen from this carbon will move out and it will generally form alkene CH3, C double bond CH2, CH3. So basically what you need to remember is along with the liberation of water. So what you need to put in mind is 1-degree alcohol gets transformed into aldehyde, 2-degree alcohol gets transformed into ketone, and 3-degree alcohol gets transformed into alkene. Thank you so much for watching the video. If you found it helpful, do share it with your friends. Also, I'll try to attach some of the important questions in the description box. If you will be able to solve it, kindly solve it and attach in the comment box. And if the video is helpful for you all, do share it with your friends. Thank you so much.